Part A asks us to find the coordinates of the center of the circle. Now, circle has another form of equation. Other than this form, we usually circle has the other form of equation that looks like this, where the AB are the coordinates of the center. So now this form here, we see that both are actually, all terms are actually perfect squares. Well, this form is not. So to change this form, we just need to complete the square to a perfect squares that we see here. So taking the equation, part A, x squared plus y squared minus 6x minus 8y. Now we can move the 11 over to the right side. So this will be equals to 11. So we group the x terms up, x squared minus 6x, so that we can see the x terms can be factorized into perfect square, and the y terms together. So by completing the square means that we need another term which is half of this coefficient, so that would be 3. So we need a 3 square. Since we introduced this on the left side, we have to write 3 square on the right side as well. Then similarly, 8y, half of 8 is 4, so we need a 4 square. So we need to add 4 square on the other side as well. So this 3, we'll group them up into x minus 3 square. The other 3 terms would be y minus 4 square. So adding this up, we'll get 36, which is also expressed as 6 square. So comparing this with the first line original form, or the other form of the circle equation, we can find the center of the coordinates, center's coordinates now. So the coordinates of center would just be 3 and 4. And therefore the radius is also 6 units. As 36 is 6 square. So same form means r square means r is 6. Now show that x equals to minus 3 touches the circle. Right, part B, show that x equals to minus 3 touches the circle. Now we can first substitute in this 3 into minus 3 into the equation form. Alright, so it is fine to substitute inside here or the original form that we have from the question. So let's just do it over here into this form. So what I'll get is when x is negative 3, so I'll just substitute into here. So I'll get minus 3 square plus y minus 4 square equals to 6 square. So this will give me negative 6 square, which turns into positive, still the same. So these two are the same. So what I will get is just y minus 4 as equals to 0. Now notice that if you solve this equation, both y will give you the same value. So it means that x equals to minus 3, this line is actually a tangent. Therefore it touches the circle. So since you just need to write, since this equation has equal roots, alright, equal roots implies that the discriminant is equals to 0 right? Which also implies that the circle is touching this line, because this line is substituted into the original circle equation, right? So it gives us equal roots, means that the discriminant equals to 0, which shows that this line is actually a tangent to the circle. So tangent to the circle, so you just write x equals to -3 is a tangent to the circle, and therefore this touches circle. Part C. The line x plus 1 y equals to 1 cuts the circle at A and B. So we are asked to find the equation of the perpendicular bisector of AB. Right? So we need to use the equation of AB first. So part C. Okay, so we can express either. So we just make y the subject, so we get y equals to 1 minus x. So that we can find that the gradient is actually -1. So the gradient of the line that cuts through AB is -1. Right, so for any circle, let's not assume that it's actually diameter. So if the line cuts at A and B, right, A and B will form, the line AB will form a chord. So the chord has this gradient -1, right? Or you can look at it as a negative line, so because it comes down. So this is -1, gradient is -1, so we need to find the equation of the perpendicular bisector. We need to find the gradient of the perpendicular bisector. Gradient of perpendicular bisector of AB. Let's just say this is just MAB complement. So this is the perpendicular bisector of AB. So the bisector and the line itself, product of the gradient will give us -1. So this line gradient we have found, because MAB would be -1 from here. Okay, so the perpendicular bisector gradient would just be 1, because 1 times -1 gives us -1. So having the gradient ready, we need to find the midpoint of the perpendicular bisector. Right. So the midpoint of AB, because the midpoint of AB will pass through the center. So this is actually the chord. Perpendicular bisector of chord will always pass through the center of the circle. So notice that the perpendicular bisector, this dotted line represents the perpendicular bisector. It passes through the center. So using the center coordinates, using the center, which is C, which is 3, 4, as we found in part A. So the equation of perpendicular bisector of AB would be this, where x1, y1 is actually the point that is on the line itself, which is the perpendicular line, which is the center, because the center would the perpendicular bisector will cut through the center. So 3, 4. So substituting M as the perpendicular bisector's gradient. So y minus 4 equals to perpendicular bisector gradient 1, x minus 3. And there we have the equation x plus 1.